everybody. Super nice to be here. I'm going to jump right in. So you can see we have kind of a long title today. But I think that's not a bad thing necessarily, because I think it's also very straightforward as to what we're going to discuss today. So allow me to jump right in, first of all, to understand what we're going to talk about. So the agenda for today would be to first talk about traditional web applications. So we're going to talk about the well-known centralized architecture and the security advantages that it introduces. And then we're going to do the same trick for decentralized applications. So we're going to talk about the decentralized world and the architecture there. And then we're going to talk about the disadvantages it has on the security aspect. And then we're going to talk about what it means to attempt to fill in the gap between the lack of security in the decentralized world and the security that we already have in the centralized world. And also we're going to talk about how this relates to the web. And lastly, we're going to talk about that gap, and we're going to talk about what we learned, and then we'll try to understand how this applies to the traditional web application security world. So we'll try to understand what we can learn from that, and I want to make sure that it makes sense to you why am I the person to talk about this today. So a little bit about myself. My name is Weizman, and I've been doing browser and client-side JavaScript security for a long time now. And I touch a lot of really different aspects over the years. So I started off at the 8200 cybersecurity unit doing offensive security, also in the client side in the browser. Afterwards, I worked for a small startup focusing on retrieving ads that were lost by ad block back to the website. So a lot of extension security there. And afterwards, I did some client-side security, client-side detection of bots and supply chain security at runtime for websites at Perimeter X, which is known for web security. And I did some bug bounties, so I found some critical vulnerabilities in services such as WhatsApp Web, Chromium, Sneak. And I did all that on my spare personal time, so make sure you don't confuse spare time with the name of a company. I'm literally talking about my spare time. And I think the point here is that I've always been focusing on client-side security for the better part of my career. But it was always from the perspective of defending what really matters, which was always the server, right? Because in the traditional world, the assets and the things that you wish to defend live within the server. But I think this is the first time ever that I have a job in which I focus on securing the client side in sake of the client, which is a kind of an interesting shift. So just to make sure that we understand quickly here, my current job is working at MetaMask, which is a well-known self-custodial browser crypto wallet. And it's in fact a browser extension. And the paradigm in the decentralized world, such as browser wallets, is really important around securing the client side. So we're going to talk about that a little bit. So this paradigm should be rather familiar to most of you. So we have the classic architecture where you have authentication in the form of being able to register and log into a server. And then you have your authorization layer, so you'd be able to, read and write, which would mean have access to resources that you should have access to, or maybe perform operations on behalf of your user. So for example, if we're talking about Facebook, then you should be able to read the direct messages that were meant to you, or be able to change your profile picture or anything like that. And here we have the classic centralized architecture, right? So the server really has all the control, and it means that it can revoke access and permissions associated with your user at any time. Now, this is something important to understand. We live in a world where we think that the user that we're associated with in centralized architectures such as Facebook belong to us, but in reality it doesn't. Because at any point, Facebook or any other company can just change the rules and decide that your user is banned in some sort of way, or maybe mitigate what you can do with it, or what you can access. So in reality, your user belongs to the server, and it is promised by the company for you to have access to it at all time, technologically. So we talked about the disadvantages, but I want to talk about the advantages on the security side of this paradigm. So first of all, the protection of the user. So the censorship concept that I just demonstrated is in fact a good thing if you want to wish to secure the user. So consider the following example, the ATO example. ATO stands for account takeover. So imagine that you're a Facebook user and someone from Indonesia, for example, managed to steal your credentials, steal your username or password, and they're going to take them and try to authenticate on your behalf from Indonesia. So what's nice about centralized architectures is that at any point they can say, well, I know that your username and password are legit, but it seems like you're trying to log in from a place that I don't trust, for example, so I can still have the power to censor your ability to log in and I can block you from doing so. And that's a good thing. So if someone managed to steal my credentials, then Facebook would be able to defend me. And this drives us to the next point, which is important. It means that the client side is something that isn't worth securing that much because the assets and everything that matters really live in the server. So the client is there merely for interaction, for you to be able to interact with the server and for you to be able to interact with some UI. But everything that matters really happens on the server because the server has all the power and it has all the assets. Your user, your pictures, like all of that. Now we're going to do the same trick for the decentralized world. So in the decentralized world, things are a little bit different. So we don't really have a registration process. So in the authentication level, it really means that in order for you to register to the blockchain ecosystem, you basically just have to be able to generate a private key and you're in. You're part of the ecosystem. And in order to log in, then your private key that is derived from that is the key that you generated in order to become part of the blockchain is in fact how you log in and authenticate in front of the blockchain. On the authorization level, it's really the same as before. So being able to read and write, access resources, and perform operations is kind of the same there. And next is the decentralized. So in the decentralized architecture, the client really has all the control. Sorry. So in the decentralized architecture, as opposed to the server, the centralized architecture we talked about before, this time the client really has all the control. The client holds the assets. The client is the assets. So there's no server in this architecture, just the blockchain. And because of how the blockchain enforces protocols, it means that anyone can participate. So it means that there's no server that holds your assets and decides what you can do with them and grants access to them. The fact that you have your private key and it is being associated with assets on the blockchain, such as coins or stuff like that, then it means that the client is in fact everything. Now, let's do the same trick and talk about the disadvantages in that term, security-wise. So this time, the protection of the user is non-existent, the same if we're comparing to how we had it before. Because if we have the ATO example one more time, and we're going to focus on the Indonesian attacker, we're going to learn that if they manage to steal your private key instead of your good old credentials, it means that they stole your client side effectively. There's nothing that the server can do about it. It's a major shift in the paradigm. And it means that the client becomes something that we have to be able to secure successfully because there's no server and the private key is literally everything. So we have to get to a point where clients are a secure entity as opposed to in the centralized world. The fact that private keys are everything, they are in fact a single point of failure. And a stolen private key literally means that everything that you have is stolen. There's no one that can help you reverse that. There's a saying in the crypto ecosystem, not your keys, not your coins. It's kind of true. It means that if someone managed to steal your keys, they're not your coins anymore. Like everything associated with your private key belongs to them. So now that we understand that, before we talk about filling in the gap and hardening the security of the client, I just want to make sure that we understand what client means in this context. So we're talking about a crypto wallet. A crypto wallet is in fact a client, and in fact it's just a browser extension, and it allows users to do three main things. So the first one is to be able to store the private key for you. So you just store the private key within the wallet, as you can see in the paradigm, in the diagram. And it's kind of like credentials, so it's really similar to a username and password. It allows you to connect to decentralized applications, so you can use your browser to visit decentralized applications, and then using your private key, you can connect your wallet to the decentralized application, kind of like a login process. And the next thing is that it allows you to interact with the blockchain, kind of like being able to read and write in front of the good old server. So you're connected to the decentralized application, and you can ask it to perform operations, and using your private key, you can do so in front of the blockchain. So this is the client that we're talking about. And now we need to understand the following thing. This is an important one. So if we're combining the two following narratives, the fact that the client is effectively everything, it is the things that we want to make sure that we secure, it is the assets, it is the coins, and if someone managed to steal it, there's no one who can help you with it. But at the same time, the client in the current design of the web is a trustless entity. We don't have an incentive to make the client very safe because of the centralized architecture. There's no reason to secure the client because the client is merely for communicating with the server. So if you combine these two narratives, you end up in a place where in order for the decentralized world to have a justification of existence, we have to successfully harden the client security-wise. So what does that mean? So the question that we need to ask is, what could go wrong with crypto wallets? So crypto wallets are in fact browser extensions, but the key difference is that they hold a precious secret, which is the private key, right? And browser extensions are in fact just web applications. They have the good old HTML, JavaScript, and CSS, but the difference is that they have more power. So the question that we need to ask, in fact, is what could go wrong with web applications that store a precious secret such as a private key? So this leads us to talk about confinement of code. So we're going to talk about malicious code execution first. So malicious code execution is something that we're going to be rather worried about because it would allow us in crypto wallet potentially access to the private key. And access to the private keys means that the private key can be abused, right? So it could be abused in two main ways. The first one would be the ability to perform malicious operations on behalf of the key. So imagine that we're running code, we have access to the private key, and then we just sign a malicious cryptographic transaction. And once we do that, then maybe the transaction would be like take all the funds that are associated with this private key and move them to the address of the attacker. So that's one thing that we need to worry about. And the other is the leakage of the private key. So one thing that could happen is how when the attacker gets access to the private key, they can in fact leak it to their server, and then they can do whatever they want with it. And at that point, we kind of lost, right? So if we're going to focus on malicious code execution, it's important to talk about the two different types. So we have good old XSS, which I am going to controversially claim that it's kind of a solved problem. We're not going to get into that today, but the basic idea is that the web these days finally provides you with everything that you need in order to successfully secure web applications. As long as you use what the web gives you, such as CSP and trusted types, then you should be good to go. And that's something that browser wallet extensions manage to prove. But the other one we're worried about is supply chain attacks. And this is, as opposed to XSS, far from being solved. So let's focus on supply chain attacks. So supply chain attacks are definitely bad, and the traditional centralized web applications definitely care about this problem, but I would claim that not enough, and for a good reason. Because any damage that can be done to centralized applications on the client side using supply chain attacks, for example, could almost always be reversed, right? Because if someone manages to I don't know, change your profile picture or send messages on your behalf or take over your account, then there's always a centralized entity that can reverse this action, because anything that happens to your user is merely semantic, and the server can always really decide what the state of that of your user would be truly. And so things could be really addressed in hindsight, and that doesn't really apply to the decentralized world, because as we said, we should care a lot, because damage is irreversible in the decentralized world. If someone manages to steal your private key, there's no centralized entity and there's no server that can reverse this for you and fix it for you. So if that happens, literally everything is gone. And it means that we have to prevent it from before, because otherwise there would be no justification of existence to a decentralized ecosystem. So it's really important for us to be able to solve this. So how do we mitigate supply chain attacks? It's a tricky question. So I would say that in order to address supply chain attacks, there are obviously a lot of different reasons, but one of them would be the ability to confine JavaScript dependencies and dependencies in general, which is also known as sandboxing. So let's talk about sandboxing real quick. So to focus on some of the stuff that we already have in the sandboxing world, so a lot of the so far attempts to sandbox code would focus on transferring the untrusted code parts to iframes or workers. So a lot of attempts there, because there wasn't really technology that would allow you to do things differently. But there are two problems that I want to talk about with using these techniques. So first of all, the problem of identity discontinuity. So identity discontinuity, in fact, means that if you're splitting code to an iframe or a worker, then those are going to become two separate realms. And when you split code into two separate realms, it effectively means that each realm has its own set of intrinsics, its own set of APIs. So each would have a separate instance of the DOM, a separate instance of the array and object and function and intrinsics similar to that. And it means that code that used to trust that variables that it creates derive from one prototype chain would learn that a lot of its code is now being generated with two different prototype chains at runtime. And a lot of the current web code isn't prepared for that. So a lot of things are going to break when you try to use this approach. And the second one is how you're going to break synchronicity if you're going to try to split code into two different realms. Because if you place part of the code in an iframe, so in fact, if you used to have an atomic operation in JavaScript, a couple of lines, and you're going to take some of them and put some of them in an iframe or a worker, then they're not going to run synchronously anymore. And that would actually mean that a lot of your code is going to change, because if that's not going to run immediately, it means that something else that you didn't expect would run before. So sandboxing in the web JavaScript world is a very complicated thing to do because of these problems and a lot of other problems as well, but we're going to focus on these two. And That is why the decentralized ecosystem, specifically a company named Agoric, is working on a very interesting solution called SES, which stands for Secure ECMAScript. So the idea is to harden the security properties of JavaScript and to address the ability to confine and sandbox code. So currently it's a JavaScript shim. A JavaScript shim is in fact a virtualized solution to the problem that is being installed into web applications or JavaScript applications at runtime. But the idea for this is to become a to become a native API to the JavaScript language, and it is already a TC39 proposal. So this should at some point become a native part of the language. And we should understand what SES does. So SES does three core things. Two of them is to prepare the environment in which it's going to execute to become secure, such as lockdown and harden. We're not going to focus on these two, but all you need to know is that it prepares the environment to securely support compartments. So at this point, it's important to understand what compartments are. So kind of a long quote, but it's another way to say that compartments are a way to isolate JavaScript code, kind of like a sandbox. And it's a really powerful confinement of JavaScript code. And what's really nice about this is that it solves the cross-realm problem, because it is implemented virtually in the same realm of the application. So there's no need for iframes or workers. You just create sandboxes in the same realm. And then, therefore, you're going to introduce yourself to the same JavaScript intrinsics and the same APIs. So your software is going to have access to the same prototype chain, the same DOM, the same object and function and array instances. And it's not going to have the identity discontinuity anymore, the problem of the identity discontinuity. And also, the synchronous access problem is also being solved, because if you're running in the same realm, it means that you share the same thread, and it means that you share the same event loop. And everything is really in the same ecosystem. So you're going to end up in a place where your JavaScript code is being confined into these small compartments, these small JavaScript sandboxes, and they're all going to live in the same realm successfully. So we're talking about a really powerful and revolutionary technology. So how is this going to be relevant to us? So we can use SES, and we can use the compartments introduced by SES to confine the different dependencies that are in fact the supply chain, right? So we can take each dependency and we can confine it within its own compartment. And it works just as before, because we don't break synchronicity, and the identity discontinuity problem is fixed, right? But what changed is that it's being done far safer, because everything is being confined in this really powerful, really secure, virtualized JavaScript sandboxes called compartments. So what's interesting about this technology is that none of what I said is theoretical. SES is actively being used. It is being used by the decentralized ecosystem and is being developed and maintained and pushed by a company that is part of the decentralized ecosystem. And browser crypto wallets actually use it. They use it to confine the different dependencies that comprise the supply chain of each application, each crypto wallet, in order to make sure that those are going to become a problem if one part of your supply chain became compromised. So I want to sum up everything that we talked about. So what does this mean? So first of all, we talked about how the traditional centralized web applications ecosystem, how the assets and the capabilities all live in the server, and security mostly focuses on the server, naturally, because everything lives there and the client is not very relevant security-wise. Obviously it is, but not a lot. And with the decentralized world, such as decentralized applications and crypto wallets, it's kind of like the opposite. So the assets and the capabilities, instead of living in the server, all live in the client. And that means that security must focus on the client. But the gap is how the web current design isn't prepared for this and doesn't take this into account. So in order to fill in for the gap, we have to find a way to harden the client. We need to make sure that we fix security for JavaScript in the browser. And SES is a really good example of an initiative that successfully and adequately addresses the supply chain attacks scenario. What it does is just confine code within virtualized JavaScript sandboxes. Now, I think that this could be really relevant to the traditional industry, and that is the key point that I want you to take with you today. So, the concept of proactively securing untrusted code, parts of our applications that we can't necessarily trust and we don't necessarily personally maintain, is actually a good thing. And it could be very useful for web applications, whether they come from the decentralized world or not, when you think about it. I mean, in the good old centralized world, you still have traditional web applications, you have JavaScript code, you have external script tags that you can confine in SES compartments, you have NPM dependencies that you can confine in SES compartments. So these are good things. And the reason that I think it's really interesting for our world is that while most of the damage that can be done in the centralized ecosystem is reversible, if there's a strong, safe solution for confining JavaScript successfully, then it could be very beneficial for the traditional world as well, because we are being exposed to the same problems. There's PII information that's being exposed to the client that we wish to defend. The credentials that allow you to communicate with the server sometimes are accessible for the client. So if there's a JavaScript dependency that's being compromised, it can at any point leverage these maliciously. And they don't have to necessarily just steal the credentials, they can also just perform operations on behalf of the client, because if you have the ability to execute code within the client, it means that you can send post requests to the server because of the fact that the credentials already are accessible to you. So there are definitely things that we could defend on the client side in the traditional ecosystem, and therefore I think that this is definitely something that the web development industry can learn from the initiatives happening in the decentralized ecosystem and browser crypto wallets specifically. Thanks. That's pretty much it.